All right, our last objective for this unit is that you graph polynomials based on their key features. Just so you know what we mean when we say key features, we are talking first about zeros. We're going to be talking about the zero product property today. And second, about end behavior. So that's, whoops. Sorry about that. End behavior is if the graph goes up or down to the left and up or down to the right. Those are the key features. So first thing we do is this. We look at the degree of the polynomial. In this case, since we have 3 factors, each of which has a single x in it, if you multiplied them all, you would have x to the third. So the degree of this is 3. The leading coefficient, if you multiplied them all, would be x times x times x. That's just x to the third. And since the front is just positive, the leading coefficient is positive 1. These two things together tell you if your polynomial, tell you the end behavior. Before we consider that though, let's take a look at the zeros. The zeros come from the zero product property. Now you can probably just eyeball this, but if you remember, the zero product property says that every individual factor could equal 0. So x minus 4 could equal 0, x plus 3 could equal 0, and x plus 1 could equal 0. When you solve each of these equations, you get that the zeros equal positive 4, negative 3, and negative 1. If you want to know if you can do that in your head, the answer is yes. I'm going to put these 3 dots on the graph right now. So this is positive 4 is over here, negative 3 is back here, and then negative 1 is closer to the middle. So my graph is going to go through those 3 points, and this is important, it's not going to go through any other points on the x-axis. Those are the only zeros. The line has to go through all 3 of those points. Next thing is we're going to consider the degree and the leading coefficient. Now, you should have notes on this from class, but what we have here is an odd degree and a positive leading coefficient. And if something is odd and positive, what that means is that it increases to the right and it decreases to the left. Now I'm just going to put arrows here. You don't have to put them exactly where I do, and a lot of people don't even need them because they can just kind of picture where things are going. But down to the left and up to the right, that is our end behavior. The last thing we have to do is to connect these. Now, in reality, this graph probably goes really high and low, but it definitely curves up and down for a little bit. So what we're going to do is we're going to connect our arrows, and we're going to connect them through the zeros. Now, I'm not being super careful about my y values. Again, it probably doesn't look exactly like this, but in general, it's going to go like this. I'm going to follow this arrow up through that 0. It'll turn around, go down through that 0, turn around, go up through the last 0, and then connect with that last arrow. I'm sorry that my line is pretty ugly looking, but you get the idea. This is a cubic graph that increases and then decreases and then increases, and it has those 3 zeros. Let's try this again. In our next example here, we have the degree has 1, 2, 3, 4 x's, which means our degree is 4, which is even. In this case, if you multiplied all those, you get x to the 4th, but there's a negative here, which means you get negative x to the 4th. Our leading coefficient is negative. And I'll do this right now since we're here, but if we have an even negative graph, that goes down to the left and down to the right. Again, just check your notes from class to see each of these combinations, what they would do. Next thing we're going to do is determine the zeros. We've got 1, 2, 3, 4 factors, each of which could equal 0. People sometimes forget this one, but remember, this one is just x equals 0 by itself. So 0 is already kind of given to us. X plus 1 equals 0 means we have negative 1. And I'm not going to write the rest. We're going to have negative 4 and positive 2. And I'll put dots on the x-axis for each one of these. So we've got 0, negative 1, negative 4, and positive 2. Now remember, not only are these our zeros, these are our only zeros. So when I draw the line like we did over here, it's not going to touch the graph anywhere, or I'm sorry, it's not going to touch the x-axis anywhere except for what I just did. Now I'll put in our end behavior, so it goes down on both the left and right. And again, you can draw these arrows now or not, or you can just kind of connect in the way that it should in the end. Then you can put in the end behavior. So again, this is kind of optional right now. An arrow on the left and an arrow on the right, both down, because that's what an even negative graph looks like. And then finally, just like the first one, we are going to connect our arrows going through each zero and no additional zeros. So up through this first one, turn around, down through the second one, turn around, up through the third one, turn around and down through the fourth one. And if you do this right, then everything should connect perfectly. Again, this isn't exactly what the graph looks like, but our key features of the zeros and end behavior match up with what we just drew. So that is it. Our objective was that you graph polynomials based on their key features.